My name's Chen. I'm from SIMS, Sydney Institute of Marine Science, down at Chowder Bay, Mosman in Sydney. So I primarily work on the cooling and shading subprogram led by Dr. Daniel Harrison. He's my supervisor. He's going to give a keynote speech at 1 o'clock this afternoon, this room. So if you are interested, come back in this room. As part of my primary work objective, I'm mainly responsible for the engineering upscale of two technologies. First one, marine cloud brightening. Second one, fogging. So basically my task is sort of working as an engineer to be able to fix the problem and to be able to have it tested on the field, operate those machines, get data, and come back, process data, and reporting. So today I'm going to share some of the results for the most recent campaign in 2023, and also some of the key results. Firstly, I would like to acknowledge the traditional custodian of the beautiful land and water that we carry out our research on. So MCB, Marine Cloud Brightening, probably you've heard of it. Yesterday, my colleague Peter sort of gave a general overview of the MCB, but essentially MCB is the process of creating larger and brighter clouds that could over the ocean to cool the water down and possibly the coral. So my supervisor, Dr. Daniel Harrison, he developed his concept of applying regional MCB over the GBR to reduce coral bleaching during the marine heat wave. So the whole process I'm gonna explain just shortly. Before and after I joined this whole group, there has been tremendous amount of engineering efforts being putting on to really transform this whole MCB concept into a real-world physical machine that you can really test on the GBR. So starting from 2015, Dan's group started to develop this concept. Up to 2022, we actually had our very first prototype. We call it V22 Cloud 1, as you can see, 2022. It's equipped with about 100 nozzles. And I started work at SIMS from 2022, basically working on upgrading the V22 Cloud number 2 to number 3 to get it ready for the 2023 field campaign, and also work on upscaling into the 4th generation. All I want to say is there has been incredible amount of iterative engineering efforts has been putting into upgrade those machines, go out to the ocean, spend a good a month or a month and a half to really test those machines to make sure we are delivering this concept into a real world product. So when I first joined SIMS, my main task, as I mentioned earlier, is to upscale the prototype. So I was given a as you can see, a snow-making cannon producing billions, a few hundred billions of droplets per second from just a short glass of water. I was given one snow-making cannon to make those aerosols, but my job was to double the size. And the target is to get from 4.3 up to 8.6. And apart from upscaling, the actual spray cannon, the other thing is to oversee all the problems that we had in the 2022. As you can see here, very clearly, the blue line indicates the water line. So what happens on the boat, we have all our scientific gear on the boat, stored in four of the 20-foot shipping container, which I'm going to talk later. So basically, the whole process is water gets pumped through buy a low pressure pump, go through a few stages of water filtration, 50 micron, 10, and 1 micron. The filtered seawater gets pumped by a high pressure pump up to 150 bar, the pressure that you normally operate and the gurney to clean your car, clean your house, clean the pavement. That's the water line. And we've also got 6 dedicated commercial size air compressors, each rated sort of around 200 bar, but we operate at similar water pressure. Similar pressure as water, 150 bar, and each of the compressor is able to deliver sort of around 3 cubic meter per minute. And the compressed air goes through serious stages of air and water separator and pipeline filter to make sure the oil content is reduced down below 0.1 ppm. So, and this compressed air and also the high pressurized water gets mixed up, break seawater down to around 40 to 50 nanometer particle size aerosols. And then we use a giant fan at the back to push the aerosol to the low lying cloud. We call it stratocumulus cloud, 500 to 1,000 meter high, trying to brighten the clouds by using those amazing nozzles. So as you can see here, that's one of the sprayer cannon that I was operating for the 2023 fuel campaign. We've got 2 of them. Each of them's got a 5 nozzle, specially engineered nozzle tower. Each of them's got a sort of around 64 nozzles. So altogether, we've got 2 cannons, around 640 nozzles altogether. And so, as I mentioned earlier, most of the scientific gear we mobilize in cans for this fuel campaign. And the vessel, as you can see from the right top corner, the Bandicoot, that's the man work vessel, the sprayer vessel I was working on for about a month and a half, living on the boat. Ironically, I've been living in Australia for over 14 years. That was the first time I was up on the reef, and it took 45 days. So that was a great experience working with those, other engineers and also the ship crew. And as you can see on the right-hand side, we've got a diesel genset that was mainly used for power the whole equipment. On the right-hand side, those are the lovely compressors, noisy compressors. We've got 6 of them, and on the left-hand side corner, you've got the support container with all the oil water separator, water pumps, and every single bits and pieces that putting together make this concept to work. As you can see, we've got 2 cannon over there spraying millions of aerosols trying to brighten clouds to potentially cool the water down. So there was a lot of engineering efforts to bring all these together. The reason why I want to put these slides up is just because I want to emphasize it's such a lot of effort being putting on, like getting people from different multidisciplinary background together working towards a common goal. So as you can probably see here, I'm on a spray vessel. That's the vessel actually creating what we call cloud condensation nuclear, lovely nuclear sort of thing to make the clouds brighter. And we've got a team working downwind on the other vessel, magnetic. So and this vessel is equipped with all different sorts of aerosol sort of equipment to be able to tell whether we are creating the right size particles and also whether we've got enough sufficient amount of aerosol that's going to change the clouds. And also we've got a team working on Heron Island, One Tree Island, to monitor the background, serving as a control. We've got a team working in the air as well. So my supervisor Dan Harrison, he's working in the air So we're working in the aircraft equipped with more than 20 instruments on the wings, inside of the cabin, to make sure to go through the targeted clouds to be able to tell whether the clouds has been seeded by us or not. Apparently, from the preliminary results, we can say that we've changed the clouds. Next slides. Okay. So for me, as an engineer, I'm interested in a lot of engineering parameters in making sure this whole process is safe and less risk to run. So I'm interested in a lot of parameters such as air, water flow, pressures, and also the temperature of the compressors, different sorts of engineering parameters. We monitor them every single second. So at the end of the day, there are a lot of data I have to deal with. And from the results, as you can see here, because I'm running out of time, basically from the 2023 field campaign, as you can see here, I've dealt with the two sprayers separately because they are essentially two different individual systems. As you can see here, for V22.1, one single sprayer, it's got 6 different spraying types. And what I want to highlight here for V22.1 and 2, the spray type number 1, 6, and 1 are the ones we expected. And from all the engineering results, we've done some plotting. So all I want to say here for these slides is for V22.1, it's operating like stably. So 87% of the time it's running at what we wanted. For the new upgrades, which we put it on, it's running perfectly. 90% of, almost 90% of the time, it's running on at what we wanted. And from the downwind vessel magnetic, it's capturing the aerosol sort of dry particle size, sort of around 50 nanometer particle size. That's aligned with what literature has recommended. And we've doubled the production rate as what I was asked for. That's why I'm still presenting here, I guess. And last slides. Okay, 1 minute. So this is actually very important because what we measured here, the power draw is sort of around 345 kilowatts. For those who are not from engineering background, it's the power sort of around for a sort of like a Mercedes-Benz AMG model, a twin turbo 4.0 engine that can possibly output. That's the energy not needed to drive the whole MCB machine. And apparently those compressors are the main sucker. So they suck sort of around 95% of the energy that used for the whole plant. And last of all, I just want to highlight what we got is extremely higher than what the previous theoretical research being proposed. They were saying only 40 kilowatts is needed, but actually what we got is more than that. So that highlights the importance of getting physical research done on this topic. And in summary, it's a great upgrade. My job's done, and was very first compressor monitoring of the parameters and at scale, and we've got the right size and the right amount of aerosol. And last of all, I would like to thank everyone who worked together on the boat, the ship crew members, and also everyone else involved in this project. Thank you.
Thank you, Chang.
Thank you.
Hello. Yeah, thank you, Chang. That was great.
Yeah.
We have 1 minute for a question. Yes.
Thank you very much. It's very fascinating. My question might be outside the scope of your research, but out of interest. Do we have any data on how effective this cloud brightening will be to prevent coral bleaching? Yeah, I think there are a separate team who are working on the coral side of things. As I said, it's such a large multidisciplinary project. My main area is in engineering. I'm giving a problem. I'm giving the right particle size, but there are team working on the cloud physics,
there are team working on the coral health. Yes, definitely. I think we have data for that, but unfortunately, I'm not the right person to ask. Oh. Yeah, you can talk to Peter. Peter's got some. He's working on the coral, so in our team. So yeah. Thanks very much.